Patterns, like the growth of transportation, are everywhere. You just have to look around. Speaking of patterns, a man by the name of Fibonacci discovered a very famous pattern of numbers a long time ago in Italy. This pattern of numbers is called the Fibonacci sequence, and the ratio of certain numbers in this sequence is so special, it's called the golden ratio. Let's learn a little more about the golden ratio and Fibonacci.
Who?
Fibonacci was a 13th century Italian mathematician who was studying a rabbit problem. He wanted to know how many rabbits he would have at the end of the year if he started with only one pair of newborn rabbits. Fibonacci knew that newborns are able to breed after 1 month, then every month after, if the conditions were right. He found that the sequence 1, 1, 2, 3, 5, 8, 13, and so on, demonstrated the total number of rabbit pairs at the end of each month. So at the end of the first month, you have the original pair of newborn rabbits. At the end of the second month, you still have the original pair because it took a month for them to become old enough to breed. At the end of the third month, you will have 2 pairs of rabbits, the original pair and their newborn pair. At the end of the fourth month, you have the original pair, their first pair, born the third month, and their newborn pair, born the fourth month. Following this sequence, at the end of month 12, you'll have 144 pairs of rabbits. Fibonacci and others soon found this sequence occurring in many other things in nature. By counting the spirals of pine cones, pineapples, and sunflower seed heads, for example, you can find neighboring pairs of Fibonacci numbers. The way in which leaves are arranged on a stem also displays a Fibonacci relationship. So do the spirals found in seashells. Now, Fibonacci wasn't the only one who was fascinated with these numbers. The ratio obtained by successive terms in the sequence was thought by the ancient Egyptians and Greeks to be special. It was so pleasing that they used this special ratio to design their pyramids, their temples, and buildings. You know the Parthenon? That's a great example of what has come to be known as the golden ratio or golden proportion. Here's the Fibonacci sequence. Let's see if you can determine the operation used and find the next 4 terms. 1, 1, 2, 3, 5, 8, 13. If you guessed 21, 34, 55, and 89 are the next 4 terms, you're right. How did you get it? The ratio of certain pairs of numbers in the Fibonacci sequence is used to describe things in nature. 1 to 1, 1 to 2, 2 to 3, 3 to 5, 5 to 8, 8 to 13, 13 to 21. If you divide the denominator of each ratio by its numerator, the results look like this. The ratios begin to get close to the rounded number 1.62. What if you divide the small number in the pair by the large number? Well, you'll get 0.62 rounded. If something in nature can be described using the ratios in the Fibonacci sequence, well then it's said to be golden.